Yes, good morning, good afternoon, good evening, depending on where you are. My name is CPA MAKAN. Today I'm proceeding on with our topic on matrices. The previous topic we were discussing about introduction to matrices, whereby we defined the meaning of the word matrices. We went ahead and selected some types of matrices, which we say that these types of matrices are going to help us in our daily computation, whereby I've planned today to take you through all the questions that relate to matrices. After this, we shall also go and discuss about application of matrices, whereby we shall be discussing about the input-output analysis or input-output model. Then after that, we shall also see another application of matrices called Markov analysis. These two subtopics are very important because they are built from these particular matrices. In this case now, we are going to put in practical what we discussed as introduction. And if it is unfortunate that you have not watched my previous topic on matrices, kindly review that topic because it carries actually the entire base of what I'm going to discuss today. We are going to see how to calculate the determinant, how to develop the transpose, and how to do a submatrices. So therefore, welcome and enjoy the lesson. Thank you. Now, and before that, I will also request you to, if you have not subscribed, kindly subscribe, put your notification bell on so that whenever there is a video ready, you are able to be notified on time. And if you have not subscribed, kindly subscribe. And if you have friends, you can also share with your friends to join and enjoy the CASNEB syllabus, quantitative analysis, business statistics. And also when you go to colleges and universities, you will find the same things being discussed there. Therefore, enjoy the lesson today. Now today I would like to discuss 5 questions. Question 1 on matrices. An investor has 20,000 shillings to invest. If part is invested at 8% and the rest at 12%, how much should be invested at each rate to yield 11% on the total amount invested? Use the matrix method. This question is very specific that you are supposed to use the matrix method, which means there are also other methods that you can use to solve this problem, but specifically matrix. The first thing is to obtain the data in a table as it is written here. Sometimes also the data requires you to form equations. Like in this case, you are going to form equations, and then from the equations we develop our table. Then from our table we come now with our computation. So like in this case, they are saying an investor has 20,000 shillings to invest. If part is invested at 8% and the rest at 12%, then we ask ourselves, what amount of money was invested at the rate of 8% and what amount of money was invested at the rate of 12%? And this investment of 8% and 12% will yield a return of 11%. Question says now, how much should be invested, which means they want you to calculate that amount. Therefore, you now say, okay, example 1. Let X and Y be amount invested. Okay, amount what? Invested. Therefore, there is an amount for investment is 20,000. So therefore, our first equation will be now X plus Y should give you the 20 amount that was invested. Correct? Then they are saying there is part of this money which is now X of 20,000 and Y for this one. So this X and Y are being invested to give an interest rate of 8% and 20 and 12%, giving a return of 11%. Therefore, it means I will take 8% of X, then 12% of Y, and should be equals to 11% of the investment. Therefore, my computation now will be, instead of saying 8%, I'll just put them in decimals, 0.08. So it will now be 0.08x plus 0.12y should be equals to 11% of 20,000. That is what the question is saying. Therefore, our final answer now, our final equations will be x plus y should be equals to 20,000 and 0.0x8y plus 0.12y should be equals to 11% of 20,000, 2,200. So we are going to use matrix to solve this equation. So therefore the matrix, we need, the first step for matrix, once we have now obtained these equations, is to write these equations in matrix form. Therefore 1, 1, 0.08 and 0.12. Then x, y then equals to 20 and 2,200. So our matrix will be 1, 1 for x, y. Then the second equation is 0.08x plus 0.12y. So our equation now is 0.808, then 0.12 like that. Then x over y like that should be equals to 20,000, then 2,200 like that. So this is now a representation of this equation in matrix form. The second step, remember in our video, the previous video, we discussed about the steps to be followed. So in this case, we have this one. Now we go to our steps. The first step was to come up with what we call cofactor matrix template. Cofactor matrix template. And we say that cofactor matrix template is made up of signs, whereby we say we have, it starts with sign x, sign plus, sorry, then sign y, negative, then we have sign negative, then x plus here. So this is if it is for 2 by 2 matrix. If it is 3 by 3 matrix, it will be plus, minus, plus, minus, plus, minus, plus, minus, plus. So you can see. So therefore it means that from this matrix we have here, it is 2 by 2 matrix, which means plus, minus, minus, plus. So therefore we bring these signs inside the equation. Therefore 1 will be multiplied by plus. So plus or a positive and positive 1 gives you positive 1. Then positive and negative will give you negative 1. Then positive 0.08 and negative will give you a negative answer. Then positive 0.12 and positive this will give you what? A positive. So therefore our template will be, the first one will be plus, which means plus positive. The second one will be a negative. Then the second row, which is 0.08 and 0.12, this one will be negative 0.08. Then this one will be a positive of 0.12. This is what we call what? Cofactor matrix template, using 2 by 2 matrix. This one. Immediately after that, we now come up with what we call factor matrices. So we want now to generate as many matrices as possible based on what we learned yesterday. How would we go about? We were saying you close the first row like that, then close the first column, then copy this entries that you have seen there which have not been closed. For example, in this case, close this, so there will be no 1 and negative 1. Then close this, there will be no 0, there will be no negative 0.08, but there will be what? 0.12. So therefore your first one is 0.12. Then I've closed this, I've not closed this column here, so I will close the first row with the second column. Close the first row, so there will be no 1 and negative 1. Then the second column, there will be no 0, 1 and 0, 0.02. So what is there is negative 8. So when I close that like that, here will be negative 0.08. Go to the second row, you close it like that. Then the first column, what is remaining is negative 1. So you put there negative 1. Then you close here and close that. What is remaining there is positive 1, like that. So that is your cofactor matrix. You can see that. Once you have done this cofactor matrix, determine what we call what? A determinant. Get what we call a determinant. So how do you get the determinant of 2 by 2 matrix? Product of the main diagonal minus product of the minor diagonal. So main diagonal is that. So 1 times 0.12 is 0.12 minus product of the main diagonal minus 0.08 times minus 1 gives you positive 0.08, which means I'm subtracting that now, like that. So your answer is 0.04. So this is your matrix. The second step, get the inverse of this now. What is the inverse? Inverse now is for this is 1 over 0.04 into brackets. Now, the inverse for this one now, look at what is happening here. So, we have seen already it is like this. So, the inverse of this, how do you get the inverse of this class? Is this one now. The inverse for this, you interchange the rows and the columns. Rows and the columns, the way we are learning yesterday. So, interchange this one to be like this. So, that's now the transpose. This one and that, transpose that. So, this one will be a column of 0.12. This one will come down as negative 0.08. Then this one will be negative 1. Then negative. See that negative 1? There is a positive 1. So here, this is a positive 1, like that. You can see. So our inverse is this. Is that the end? No, we have been told to solve. The question is saying, how much should be invested at each rate to yield 11%? So they want you to find the value of X. So once you have now the inverse here, your work is to determine now. It's now saying, therefore, 1 over 0.04 into brackets, as it is here, which is 0.12 negative 1 negative 0.08, then positive 1, you multiply by the answer as it is here, which means this answer you multiply by the matrix. Then this xy you take it to the other side. So I multiply by 20,000 and 2200. That matrix should give you x and y in that format. Then from there, you multiply now. Yours is to multiply immediately. So, don't bother with this. This one will come just automatically. Just do the multiplication, what is in between the two of the, multiply the two matrices here. So, therefore, row times the first column, row times the second column, if there is. But in this case, we have only one column. So, therefore, it will be the first row times that column plus the second row times that particular column. Therefore, it will be 0.12 times 20,000 plus minus 0.1 times 2200. The second one will be negative 0.0 negative 0.08 times 20 plus 1 times 22. Then you get your answer. So therefore, if you now press your calculator very well, if you now say this 0.12 times 20 minus 0.1 times 22, your likely answer is 0.04 into brackets. If you press your calculator very well without any problem, you will answer here will be 200 here. Then negative 0.08 times 20,000 plus 1 times 2200, your answer is 600. Your answer will be 600. So 200, 600 like that. So should be equals to x, y. Now from there, you divide 200 divided by 0.04, you get 2000. You get 5000, sorry. You will get the 5000. So if you multiply this carefully, you get the 5000. Then the other one is 15,000. Is equals to x, y. It means the value of x is 5000, then the value of y is 15,000. If you try to substitute in any of these equations, either the first equation or the second equation, you must get the answers that you have equated here. For example, x is 5000 plus y is 15,000. So 5000 plus 15, you get 20,000. Then 0.08 times x, 5000, plus 0.12 times 15,000, your answer is 2200. So therefore it means our correct answer, the values for x and y, is you invest 5,000 at the rate of 8%, then invest 20,000 at the rate of 12%. That is example 1. We go to example 2. Go to example 2. Example 2 reads, a company produces 3 products, P, Q, and R, using raw materials A, B, and C. 1 unit of P requires 1, 2, and 3 units of A, B, and C respectively. 1 unit of Q requires 2, 3, and 2 units of A, B, C respectively. 1 unit of R requires 1, 2, and 3 units of A, B, C respectively. The number of units available for raw material A, B, and C are 8, 14, and 13 units respectively. Using the matrix method, find how many units of each product to produce in order to utilize completely the available resources. From this question, we are first of all supposed to develop a table. From the table, we now form our algebraic expressions. Then we now find the values of the unknowns. Therefore, our work is very simple. We follow one by one, the way you have been told. A company produces 3 products. So you can say they are products here. Products here. We have product P, Q, and R. This P, Q, and R. Then they are saying 1 unit of P. 1 unit of P. If you want to produce 1 unit of P, this one here, what do? You require 1, 2, and 3 units of raw materials A, B, and C. So you combine A, 1, B, 2, then 3 for C, for you to produce 1 unit of P. Therefore, it means if you want to produce 1 unit here, you need 3 products, raw materials here, A, B, and C. And you need 1 of product A, of raw material A, and then you need 2 for raw material B, and we need 3 for raw material C to produce 1 unit of P. Again, continuation. 1 unit of Q, this one here. You need 2 units, 3 and 2 units of A, B, C. So we need here 2, 3, and 2 units to produce. Then 1 unit of R requires 1, 2, and 2 units. You require here 1, 2, and 2 units to produce 1 unit. Then for that, the number of units, the total now of units produced for raw materials A, B, C, are 8, 14, and 13. What does it mean? That for the total raw materials for A, when you add now whatever that will be used in B, and whatever will be used in production of Q, and whatever raw materials of A that will be used to produce R, the total raw materials for that matter is 8. Then the total raw materials for product B is 14, which means the ones that will be used to produce unit B and produce Q will give you what? 14. And then the other one will give you what? 13. So this is what we call a total. So when you look at it carefully, it is like a table. Correct? Now, that is the table that we are supposed to generate. By doing this, you have your 1 mark because you have already interpreted the question correctly. Then from there, you now say, okay, how many units of P were produced when 8 raw materials were used? How many units of Q were produced when 14 units raw materials were produced? And how many units of R were produced when 13 units were produced? Then you now say, let X, Y, and Z be total what? Units. For which products? For product P, Q, and R. Correct? Therefore, once you do that, you now say, okay, it will be X times 1 plus Y times 2 plus 2 times 1, you get 8. The second row, which is now B, Y, X times 2 plus Y times 3 plus Z times 2. The third row, you now say X times 3 plus Y times 2 plus Z times 2 equals to 13. So when you multiply that carefully, your answer you get now there will be X plus 2Y plus Z equals to 8. The second is now 2X plus 3Y plus 2Z gives you what? 14. Then the last one is 3X plus 2Y plus 2Z should give you what? 13. So you can see now we have the equations. By doing this, you have another 1 mark. After this, you now write these equations into matrices. That is now 1, 2, 1, 2, 3, 2, 3, 2, 2, like that. Then X, Y, Z, like that, equals to 8, 14, and 13, like that. Okay? That is another step. The second step now, that the one we learned yesterday, now we come up with what we call a cofactor what? Cofactor matrix. Matrix what? Template. And I want you to pay attention carefully when I talk about a template. How do we develop what? A template. So in this case, there are 3 by 3. This is 3 by 3 matrix. So therefore it will be plus, minus, plus. Then minus, plus, minus. Plus, minus, plus. So this is the template. So we multiply positive. All these, it seems they are all positives here. But you might find a question with some negatives. So if these are negative, then a negative times a negative is positive. But all these are positive. So positive times positive, positive. Positive times negative, negative. Like that. So therefore, this and this gives you 1, negative 2, 1. Then negative 2, 3, negative 2. Then 3, negative 2, 2. Like that. So this is your, what is this? This is your template. Can you then generate from this template, generate as many matrix as possible using the first row, finish, second row, first row, second row, and third row by generating all the matrices that are needed. So for this case, you now say cofactor matrix matrices now, because it is the plural now, matrices, not matrix, but matrices. Now, can we generate? Yes. Look at what I'm going to do. You close the first row completely, then you close the first column completely. What is left? I'm seeing this. So let me demonstrate for the sake of learning. Okay, for the sake of learning, you close the first row like this, what we did yesterday. Sorry. First row, then close the second column. Then what are you seeing? 3, -2, -2, and 2. So you copy them there. It will be now 3, -2, -2, and 2. So that is the first matrix that you have obtained. The second, I'm still on the first row, like that. So come and close the second one, column. What are you seeing? I'm seeing -2, -2, 3, and 2. So you copy them there. But which direction are you going? Towards the right, because you are still on the first row. So you'll have now, you'll have your element. Then you go to the third one. If you close this like this, like that, what do you see there? So the last column now, the last matrix will be 2, -2, 3, 3, -2. You will have finished with this. Then let me just demonstrate and then I finish. So I'm the second row, first row, sorry, second column, -2, -2. So -2, -2, -2, -2. Then 3, 2, 3, 2. The third column is I close this, I open this, so -2, 3, -2, 3, then 3, -2, 3, -2. That is the first row. When you come to the second row, you close the same second row, then you start again, first column, write the matrix that you are seeing, second column. Like for example, if I close the first column, the matrix I'm seeing is -2, 1, -2, 2. Then go to the second, I close this like this, I will have 1, 2, then when I've closed it like this, it will be -2, -3, sorry, 3, 2. Then I go to the last, I will see 2, 1, -2, 3, -3, and so forth and so forth. So therefore, if you press your calculator very well and ensuring that you have now closed what is required, this is the kind of matrix that you will obtain. This is the kind of matrix you will obtain. So the first, you have already here. The first, you have it here. So the second, you will have now -2, 1, -2, 1. Then that is like that. You go to the second, that is 1, 1, 3, 2. And the last one is 1, -2, 3, -2. Like that. Then when you go to the third row, your column, your rows that your column, the third row now, your matrices will be using the same simple method. You close, you open, you will get the following: -2, 1, 3, -2, then 1, 1, -2, -2, then 1, -2, -2, 3, like that. So this is now your, so many, there are how many elements, there are how many matrices? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 matrices. From here, you can see each matrix is like now the 2 by 2 matrix, the first one, the one that we have just wrapped here. So it is 2 by 2 matrix. Then you follow the same procedure. Your work is very simple. Next step is product of the main diagonal minus the product of the minor diagonal. Therefore, minor main is 3 times 2, 6, minus 2 times minus 2 is positive. Correct? So you say positive 4. Second, negative 2 times 2, negative 4. Then minus 3 times negative 2 is negative 6. You see what I'm doing? Then negative 2 times negative 2, positive 4, minus 9. Second, negative 1 times negative 2 minus times 1, negative 2. Then minus 2. You go to this one, this times that, 2, minus 3. 2 minus 3. Then the last one, negative 2 times 1 is negative 2. Then minus 3 times negative 2 is negative 6. Then you go to the last line. Negative 2 times negative 2 is 4 minus 3. Close like that. Then 1 times negative 2 is negative 2 minus 2 like that. Then finally 1 times 2 is 3 minus 4. Then you say that. Then give us the answers as per what you have there. Correct? So when you work out carefully, this one will give you 2. This one will give you 2. The other one will give you negative 5. This one, like that. Then this one will give you 0, 4. This one is, there's a problem here. This one should be 2. Let's go back. First column. You close this like that, then you have like that. So you'll have, not that, sorry. Not that one. It will be 1, negative 2, 1, negative 2, 3, 2, negative 2, 3, negative 2, 2, like that. Now in the first column, I'm just correcting here, there's a problem here. So you close the first row, the second row, and the first column. So what are you seeing? Negative 2, 1, then negative 2, 2. So negative 2, 1, then negative 2, 2, like that. So that now, this times this gives you what? 4, This times this will give you 4. Like that. Now, I give you 4 like that. So this is negative 4 minus 2 will give you what? Negative 4 plus 2, which gives you what? Negative 2. This one gives you negative 1. And this one will give you negative 2 plus 6 gives you positive 4. Correct? Then this one will give you 1. This one will give you 0. And this one will give you negative 1. This one. So this is your matrix. This is now the cofactor matrix. After expanding like this, you will now arrive at that. The second step is to determine what? The determinant. Get the determinant. Remember, determinant is very simple to get using the 3 by 3 matrix. Where is your main matrix? Your main matrix is here. So your first row, you just take the first row as it is. You multiply with the first row after you have developed your matrices. Then you get your determinant. Therefore, it means 1 times 2. 1 times 2 plus 2 times 2 plus 1 times negative 5. Your answer here is 2 plus 4 plus, minus 5. So this plus this is 6. 6 minus 5 is 1. So therefore, your determinant is 1. The next step, the inverse. How do you get the inverse? So your work is very simple. The inverse now will be 1 over 1, which is, but if we had here number, for example, we have worked out and we are found to be 2, the inverse will be 1 over 2. Correct? But in this case, we don't have any, so it's only 1. So your inverse is just this. But remember, we said you do what we call the transpose. Interchange the, for you to get the inverse, you interchange the columns and the rows. So this row, put it a column, which gives you 2, 2, negative 5. This row here, which is negative 2, negative 1, negative 1, positive 4, negative 2, negative 1, and positive 4. The last column, the last row will give you 1, 0, and negative 1. So that is your inverse. Correct? Once you get the inverse, the question was saying, find the values. You are supposed to find the value of x, y, and z as we have described here. So based on our description, the work will be very simple now. So therefore means find the value of this. So you take this inverse here, multiply by the answers. The answers for the first one was how much from the question? We were given as from the question we were given 8, 14, and 13. So therefore I take this. Therefore 2, negative 2, 1, 2, negative 1, 0, negative 5, 4, negative 1. You multiply by the answers, which were 8, 14, and 13. Your answer should be x, y, and z. So row times column. So the first row times column. Then the second row times column. Then the third row times column. You get the answers straight. Now in this case now, if you multiply now the first row and the first column, the first row and the column there, what is your answer? So 2 times 8 plus negative 2 times 14 plus 1 times 13. If you work out that, your answer you get is 1. The second row, 2 times 8 plus negative 1 times 14 plus 0 times 3. Your answer is 2 here. The third column is negative 5 times 8 plus 4 times 14 minus 1 times 13. Your answer is 3. Then you is equals to x, y, and z. So if you try now to substitute in your equation, any equation from that matter, for example, in this case there was an equation of x plus 2y plus z should be equals to 8. Is it true? So we put x there, which is 1 plus 2 times 2 plus z, which is what? 3. Is it true it is 8? If that one is correct, that means the other two equations are correct. Then it will be 1 plus 4 plus 3 equals to 8. So this one, it is true. Those are the answers required. We go to example 3. So by the end of the lesson, you'll be able to work out matrices without any problem. Okay, example 3. Now example 3, you have already been given a question there, which is a table. A table is given there. And this is the table. They are saying we have cells in units here. Cells in units. We have A, B, and C. We have total here in shillings. Then we have January, February, March. Then we have 90 here. We have 90 here. We have 100. We have 20. We have 800 shillings. We have 130 here. We have 50 here. We have 40. And we have 900. We have 60 here. We have 100 here. We have 30 here. And we have 850. A salesman has the following records of sales during the 3 months for the 3 items A, B, C, and C, which have different rates of commission. So this person here was getting commission based on the type of sales. So for example, there was a commission for the sales for unit X. For A, there was also commission for sales B, and there was also commission for sales C. So this person was getting commission based on the units that have been sold. So the question is now saying, using the matrix method, find out the rates of commission in shillings for on items A, B, and C. So find the commission in shillings. So therefore it means you don't know what was the commission in January, correct? Where this person sold a 90 units for product A, then sold 100 units for product B, and sold 20 units for product C. Then in February, the same person sold 130 units of A, then 50 units of B, and 40 units of C. The total here is 900. Then in March, there was 60 units of A sold, 100 units of B sold, and 30 units of C sold. Total 850. Therefore, it means we don't know what is the commission for the product A, commission for product B, and commission for product C. So we can now say, okay, let X, Y, and Z be commissions for product A, B, and C. After that, you now say X times 90, you get now 90X, plus Y times 100, you get 100Y, plus Z times 20, you get 20Z. Your answer is 800. Then the second row, 130X plus 50Y plus 40Z. Will give you what? 900. Then you go to product, this one now, 60X plus 100Y plus 30Z. You give you what? 850. Those are now the equations that are needed. From these equations, get your matrix. 90, 100, 20, then 130, 50, 40, 60, 100, 30. Like that. Then say X, Y, and Z. Your answer equals to 800, 900, and 850. You can see. Immediately after this, you now bring in the procedures. Procedure number 1, calculate the cofactor. Cofactor what? Cofactor matrix template. So I think by this time you have known how to come up with the template. This one will be 90, negative 100, positive 20, negative 130, positive 50, negative 40. Then positive 60, negative 100, positive 30. Immediately after this, what do you do? Develop your cofactor matrices. Cofactor matrices. So I hope you have now mastered the cofactor matrices. You close the entire first row, then you play with the columns. Once you have closed this one, you close also this. You see, this is the one that begins. Then you go to the second, you close this. So this one is already closed. We have 130, negative 130, 40, and 60, and 30. You close this one. So the whole of this, what is remaining is negative 130, 50, 60, and negative 100. Then you post them there. So once you are through, once you have now done that, when you follow that rule carefully like that, your answer you get, the first one you will be as follows. You will have 50, negative 40, negative 100, 30. Then you get negative 130, negative 40. Then we have 60, negative 40. Positive 30, sorry. Then the last one is negative 130, then 50, 60, negative 100. Can you confirm whether it is true what I've copied for the first column? You just say this one is closed like that. So what is remaining is that. So 50, negative 40, negative 100, and 30. The second, I close this, so I will have negative 30, negative 40, 60, and 30. You can see. So the same applies to the rest of the columns. So when you now proceed on, you will have now negative 100, 20, negative 100, 30. Then we have 90, 20, 60, 30. Then the last one is 90, negative 100, 60, negative 100. And the last row will produce negative 100, 20, 50, 40. That, or you can use the straws like this, no problem. Then you have negative, we have 90, 20, negative 130, negative 40. Then the last one is 90, negative 100, negative 130, negative 130, and 50. Then you do it like that. Then when you look at it carefully, this template, it is telling you now that we have now 2 by 2 matrix. So a work is very simple. Main diagonal times minus the major diagonal. So for the first one, 50 times 30 is 1,500. Then minus and minus gives you positive. So it means negative 1,000 minus 4,000. Correct? Then negative 130 times 30, you get negative 3,900. You minus 2,600, 3,400. Is it correct? That is 60 times 40. You get 2,400. Then the last one is, this times that you get 13,000. You minus 3,000. That is the first one. You come to the second like that. So this times that is negative 300 minus 2,000. Then 90 times 30 is 2,700 minus 1,200. 90 times negative 100 is negative 9,000. You minus 6,000. one is negative 100 and negative 40 gives you positive 4,000 minus 50 times 20, you get 1,000. Then this times that is negative. This times this is negative 3,600 minus 2,600. 2,600. Then the last one is 90 times 50, you get 4,500 minus 13,000. Then you introduce your brackets like that. Then finally, work out what is already in the brackets. This one will give you negative. This one will change to be a positive. This one. This one also will change to be a positive. This one will also change to be a positive. And this one will also change to be a positive. So when you work out this one, your answer you are supposed to get after all that is negative 2,500, negative 1,500, 10,000. Then you get negative 100, 1,000, 1,500 here positive, and negative 3,000. Then we have 3,000 positive here. Then we have negative 100, 1,000, and we have negative 8,500. So that is now your final answer after you have done your cofactor matrix. So you can see. Now from here, what do you do? Determinant. The steps are very important. Get the determinant. How do you get the determinant, class? You go to the main matrix. Where is your main matrix? It is here. You pick the first row. Then where is your cofactor matrices? Is here. And therefore your final matrix is here. You pick also the first what? You pick also the first row. Then you multiply those products. So it will be 90 times that. So 90 times negative 2,500 plus 100 times negative 1,500. Negative 1,500 plus 20 times 10,000. Your final answer, class. Your final answer for the determinant is negative 175,000. Get the inverse. Immediately you get the inverse. How do you get the inverse? The inverse is now, this one is 1 over negative 175,000 into brackets. You go to your final answer, which is this one. So you interchange row. The first row becomes the first column. So this gives you negative 2,500, then negative 1,500, then 10,000. Then the second row becomes the second column, which is negative 1,000, 1,500, negative 3,000. Then the last row becomes the last column. So it is 3,000, negative 1,000, sorry, and negative 8,500. This is your inverse. Once you get the inverse, for you to get the answer now, you say therefore. You now say therefore. So therefore, find the value of x, y, and z, because you have already the matrix. You have already the inverse here. So it will be 1 over negative 175,000 into brackets, as it is, negative 2,500, negative 1,000, and 3,000. The second column is negative 1,500. We have 1,500, positive 1,500. And the last one is negative 1,000. And the last one will be 10,000, positive. And that one is negative 3,000. Then the last one is negative 8,500. Like that. Then multiply with the answers. You are told answers were, what were the answers? The answers given were 800, 900, and 850. So multiply this. What do you do? I've told you, don't worry about this one. It will just come automatic. What you do, work out only what is the matrix first. So the first row, first column. Second row times column. Third row times column. So what do you do? What you get? Negative 2,500 times 800 minus 1,000 times 800 plus 3,000 times 850. When you do that, your answer you get here is negative 350. Second row, negative 1,500 times 800 plus 1,500 times 900 minus 1,000 times 850. Your answer is negative 700. So this one should be negative 350. The last one is now 10,000 times 800. This is minus 3,000 times 900 minus 8,500 times 850. Your answer here is, your answer is 1,000,000 negative 1,925 what? 1,000. So here we have negative 175. Negative. So this negative will cancel all these negatives and the answer will be what? Positive. Therefore it will be 350 divided by 175. 700 divided by 175. 1,925,000 divided by 175. And your answers you get there is 2, 4, and 11. Therefore it means your x is equals to 2, y equals to 4, and z equals to 11. So if you try to substitute in any of the three equations that we had, for example, we had an equation like 90 into x2 plus 100 into x4 plus 20 into 11. Will you get 800? Confirm. This times that is 180 plus 400 plus 220. So this and this 400 will give you 800. So our answers are correct. Therefore, that is now how to calculate our matrix. And therefore, I request you that before you watch the video, first of all, obtain the questions. The questions will be attached to the video. So therefore, yours is just to download the notes, download the questions, and then once you have downloaded the questions, print them out, then match with the answers that I've just produced here. And if you find that there is a place you have not understood specifically on the video and the questions that you have downloaded from our from our YouTube, kindly reach us also on 0735 346 777 on WhatsApp and also on messages, so we are able to handle your case. Now, I don't want to finish all of these questions, but I would like you to take the note, just do question. I'm leaving only 2 questions behind, question 4 and question 5. So 2 questions. I just want to interpret here, then from there, you proceed and finish later. It says, for question 4, Food Perfect Corporation manufactures 3 models of perfect food processes, X, Y, and Z. Each model of X processes requires 30, 40, and 30 minutes of electrical assembly, mechanical assembly, and testing as respectively. Each model of Y. So in this case, we have models. Just say models. We have models X, Y, and Z. And for you to produce these models, it has to go through 3 stages. Stage number 1 is electrical assembly. The second is mechanical assembly. The third one is testing. Then you follow step by step. They are saying each model of X, this one now, this X here, requires 30 minutes of electrical, 40 minutes of mechanical, and 30 minutes for testing. Then for Y, it wants you to say 20 minutes, 50 minutes, and 30 minutes. Then number 4, the Z one now wants you to say it is 30 minutes for that, then 30 minutes there, and 20 minutes there. Then the total given there is, here is 2500, this one is 3500, and this one is 2400. This is total. You see, once you have done this, your work is very simple. Let now, whichever the letters you want, then you equate with that 5, you get the answer. Then the last one is number 5 is saying acitric. Number 5. Number 5 says, a citrus company completes the preparation of its products by cleaning, filling, and labeling bottles. Each case of orange juice requires 10. So they are preparing juices. And juices are now from different fruits. So in this case, we can have juices here. Then we can have the first one is from orange, right there, orange, followed by mango, and the last one is pineapple. Correct? Then for you to produce this one, for it to be complete, the first stage is to cleaning. So we have the cleaning part here. We can also have filling. So they are filling the bottles, and then they are testing. Then they are saying now, each case of orange juice require 10, 4, and 2 minutes. Then for the pineapple, you need 12, 4, and 1. For the mango, sorry. Then for the pineapple, you need 9, 6, and 1. Correct? Then you say now total. At the end there, that are saying here is 398. This one is 164. And the last one is 58. So you can see, let what is now say let this. Now, let this and this one. Now, so I want you to do these 2 questions, the question 4 and the question 5. Then send those questions to me. Answers to me, I will mark and share with you. These are expected answers. For question 4, you are supposed to get as follows. For question 4, you are supposed to obtain the values for question 4 to be 40 oranges, 40 for X, then we have 20 Y, and 30 Z. For question 5, you are supposed to get how many oranges for question 5. So when you work out carefully, you are supposed to say now, for oranges, your answer should be 20. For mango, your answer should be 12. And then for Z, that is pineapple, your answer should be 6. So therefore, do your workings for question 4 and 5 after you have downloaded your questions. Do them, then share with me. I want to see how you have arrived at this. And thank you so much and have a wonderful time ahead. Next lesson will be input-output model.